Hello students, today's class we will see the second program of advanced deep learning. So already we have checked the first program. The second program is image classification. So our job is we are training a deep neural network and we'll classify the images into different categories. So these are the categories. I'll directly go to the program. I'll explain the code. So here is the program. So you change your runtime. Runtime type is TensorFlow 4 GPU is set, and the program I have shared in Google Classroom. So let me start the explanation. This TensorFlow will be used as TF. We are using deep learning model, so Keras library we are importing. So this is the model for classifying 10 category. Then matplotlib we are using, NumPy you know. Now here we are loading the data set. There is a standard data set is available in the net. We are taking the CIFAR 10 data set, trained data set that we are using in our program. So X-train, Y-train, X-test, Y-test, the data set will be loaded. This data set contains 60,000 images. So 50,000 will be stored for training and 10,000 will be stored for testing. So approximately 60,000. And here we are normalizing the image. So image size is 255. So here train test equal to train divided by 255. So we are normalizing the input. And these are the classes available in the data set. 10 classes you can see. Here airplane, car, bird, cat, deer. So under all this category, 60,000 images are stored in the data set. I have already executed the program. So I will directly show you the output. Now from the data set, we will take some sample images and print. So here are the sample images. So you know this code. Figure size is 5.2. So each figure here 5.2. X side 5, 2. Then for loop we have initialized just for printing 10 images. So this subplot will take each images inside one by one based on the for loop. So one by one we are retrieving the image and printing here. So randomly 10 images are taken from the data set and printed here. To classify the image, we are constructing a CNN model, and here is the model. So model equal to models dot sequential. So sequential means layer by layer, layer 1, 2, 3 like that. The sequential order it will construct. The first one CNN model we have, then sampling we are doing, that pooling we are doing, then one more CNN layer, then pooling again. So totally we have 3 CNN and 2 subsampling. That final values are flattened and given to dense layer. So this last dense layer will predict your output. So let me explain this code. So the image size is here 3232 and this is mask. 3x3 mask we are using. ReLU activation we are using. So you know ReLU is used to avoid vanishing gradient problem. So input size is 32 into 3. Max pooling 2 by 2 we are doing, and the next layer 64 3x3 mask, and the next also 64 3x3 mask, next layer. Okay, and all this concept you know, it's a fully connected layer. 64 neuron will take the input, final value based on the probability, softmax function we are using. So out of 10 probability, which probability is more, that output will come. So that is the CNN model. Output let me explain later. We will compile this model. So Adam optimizer we have. Adam optimizer already we have discussed. And sparse categorical cross entropy we have used. So, optimizer loss functions already we have discussed in the theory class. So refer the optimizer, Adam optimizer and cross entropy category. We'll see the summary of the model. So first convolution layer 3232, correct? 3232, I will take the description here in Word. So your input is 3232, okay, and we are applying 3 cross 3 mask. So output shape will be 32 minus 3. 3 is your mask value plus 1. So by D, it's a formula. So instead of 3232, it becomes 3030. Okay. Now it becomes 3030 here. How many parameters are passed to this first layer? 896. That you can check in the outer layer. 3 cross 3 mask and 3 channel we have RGB channel for color image. So 27 plus 1 bias 28. 28 into 3232 it is, right. So 32 896 parameter. So the first layer will track all the edges of your image, the first level details, edges, boundaries of image, all those learning is done in this convolution layer. And when you are doing here pooling, there is no parameter will be the output for pooling. So 3030 will be divided into 2. So here 30 is divided into 1515. So no parameter. Again the next convolution will see the same logic like the previous logic. Based on the mask size, now 15 becomes 13. So 15 after pooling we are getting 15, mask size 3 plus 1, so 13. Now the number of parameter we can calculate. So 3 into 3 into 32, the next layer, next convolution layer will have 64. So the next level more details. The previous one only edges, then it's a middle level information, then deep level information, like that we are checking. So you can see 289 into 64. So 18,496 parameters are there. Again we are doing pooling. So it is divided by 2. 6664 we have. Again this next convolution layer, the same logic is applied. So it becomes 4464 and this is flattened. So 1024. Here I will show you the values. After max pooling we have 4464. Now you can understand this 4. Now you can understand this parameter. So 3364, this many value from filter and multiplied with 64. So we are getting 36,928 parameter. So we are we are applying convolution on the inner image like that. All possible parameters we are trying to identify, correct. Now this is flattened and given to the dense layer. So dense layer parameter you can understand here 1024 into 64 and 64 bias. So how many neurons we have? 64 neurons we have. Now you can see this many parameters are analyzed in each image. We have 50,000 images for training. From each image 65,600 values are analyzed. And then the final layer, that is 10 neurons are there. So based on the softmax function, it will give the maximum probability one, it will identify the output, correct. So approximately you can see how many parameters are processed. Layer 1 895, layer 2 18,496, then 36,928, then 65,600, then 650. So for each image we are processing this many parameter and we are trying to identify, correct. Now here I am running the model. Actually I have given epoch 10. I am getting 92% accuracy, but initially I got around 60. So I did one more execution. So epoch 20 it became. So if I run the same cell 3 times, epoch will be 30. So you also to get above 90% accuracy, you try this cell, execute this cell more than 2 times or 3 times. Now we can check the accuracy. Training accuracy is 92%. Validation you can see around 69, where training is giving more accuracy and validation is less. Here it is plotted. You can see approximately above 95 training time we got, but testing time it is less. A kind of little overfitting may come. So in that case, you can change your CNN layer or number of node you can modify here in this model structure. Okay, but this is a very simple model. Will give you a good accuracy. Now I'll show you the output. We'll evaluate the model. This is for test we already showed that 69% we are getting. Now randomly we are taking one image from the test data set, that index equal to 61. That image is given to the model and we are trying to predict. Actually the image is cat, but it is dog. So here is a wrong prediction. We'll check for one more value. If you change the index, you may get a different result. So I'll run this. This cell I'll run. Now, okay, again I should come from the beginning. Now this cell I'll execute first. This execution was done some time back, so I have to re-execute all this cell. It takes time. You can wait and see the output. Now we are assigning this training value. The next cell I am executing here, and the model is constructed here. So this cell is done, and here is a summary, and here step. Now this is running only for 10 epoch. So my earlier output you have checked, it is around 92%, but here I cannot expect now 90, above 90, because this is the first iteration of 10 epoch. The second, third, it may change. You can see it is starting with 35, then 56, second epoch. So let us wait till 10 epochs are completed. This is third and fourth epoch. We are getting 67, where validation accuracy almost same, and here 72% accuracy we are getting, and validation is 69. Now we are passing on 6th iteration. So let us wait for 3 more epoch. 7th is completed. Now 8th epochs are running. So after this 10 epoch, let me check the accuracy. Approximately we are getting 78. If I run one more time, then 20 times it is running, I may get above 85. Then one more time, so totally it will be 30. So around 90 I can get. So as of now I'll stop. When you are practicing, you test for other epoch. Now here you can see the change in the graph. Accuracy is almost 80% here. Almost same, like test accuracy and training accuracy is almost same. Now I'll run this cell. 70% is coming. I am taking same 61 indexed image. That is dog, predicted as dog, but actually cat. It's a wrong prediction. So I'll take something else, 55. Any random number I'll give. That is sheep, actually is sheep. You can understand 75%. So out of 100 images, 70% images will be predicted properly and remaining will be mispredicted. So to improve your prediction, you can increase number of epoch and check the accuracy. I hope you understood this program. Let me show me the summary of this model. This model is taking the input like this. So initially we gave 32 image size and 3 mask, means 3 channel we gave. That is width, height and depth. So 3 dimensions are there. And in the first convolution we got 32. I told you the formula. So this 32 minus mask size plus 1. Okay. So it became 30. That is given to the next layer. So after sampling 15 it became. Then next convolution we got the output. Then again sampling we did. Next convolution. Then in the dense layer we gave this many parameters, 65,600 parameter. In this 10 neuron, 1 neuron out of 10 images, the maximum probability is predicted here, correct? So you check the output. It may change for your code. the same image along with the output I have displayed here. So approximately we are processing 1,22,570 number of parameters, but still we are getting around 75% accuracy. By increasing number of epoch, you will get above 95%. I hope you understood this program. You practice this program. Any doubt, you can ask me in the class. Thank you.